Hello friends, this is Jim with Science Talk. In a continuing series of videos where we're starting to see some of the ramifications of a warming planet, I want to talk to you about rising sea levels. Now, I have discussed this before in prior videos, but with the planet warming, sea levels will increase. There are two main factors for this. The melting of land-based ice, glaciers, Greenland, Antarctica, alpine glaciers, but with Greenland and Antarctica being the major contributors. Also thermal expansion. You heat something up, it expands. You heat the water up, it's going to expand. And when it expands, sea levels come up. Then you put fresh water in there, sea levels come up some more. Rising sea levels bring the prospect of more violent storms and therefore expense to communities because, the wave action, the waves pounding shorelines and so forth. So, studies are indicating that based on the current levels of CO2 and current projected rate of CO2 emissions, that sea level rise will continue for the next 3 centuries. The warming is based on computer models of global warming and sea level rise. A second study based on very precise measurements over the last 25 years confirms that the models predicting the sea level continuing to rise for the next 3 centuries are reliable. In fact, the sea level rise may be accelerating. As sea levels rise, so does the level of storm damage to coast and coastal cities. Now, with that, of course, if you have storms pounding shorelines, whether even if it's just tidal action, just from your normal diurnal tidal activities, toss in a hurricane with the storm surge and so on, the financial impact can be quite devastating. Look at what happened with all those hurricanes that have slammed into Florida. Look at Storm Sandy when that hit New York. You had the storm surge coinciding with the high tide. Yeehaw! I think the subways filled up with water. So, and not to mention all the damage, the financial cost that such things occur. So, what the models are suggesting is that, and this is a lowball estimate. Scientists tend to underplay things. Then when they kind of go, oh, we underestimated, we need to bring up our prediction levels a bit. They always conservatively, and then they adjust, and the adjustment tends to be upwards. But conservatively, by 2300, sea levels could be 3 meters higher than today. So, every delay in peaking emissions by 5 years between 2020 and 2035 could mean an additional 20 centimeters of sea level rise in the end. So says Matthias Mengel from the Potsdam Institute for Climate Impact Research. His co-author, Carl Friedrich Schleusner, said, the Paris Agreement calls for emissions to peak as soon as possible. Notice to start drawing down the amount of CO2 being pumped into the atmosphere. This may sound a hollow phrase to some, he continues, but our results show that there are quantifiable consequences of delaying action. Global sea level rise has not been steadily increasing, it has been accelerating. U.S. researchers report in the Proceedings of the National Academy of Sciences that they examined 25 years of satellite data to find that the water that comes into the coastlines, the world's coastline, is rising, and the rate of rise is getting faster as the ice caps in Greenland and Antarctica start to melt at a greater rate. By 2100, on present evidence, the sea will have risen 65 centimeters. That is almost certainly a conservative estimate, said Steve Nerham of the University of Colorado Boulder, who's also a member of the U.S. Space Agency's NASA's Sea Level Change team. Our extrapolation assumes that sea level continues to change in the future as it has over the past quarter century. Given the large changes we are seeing in the ice sheets today, that is unlikely. Translation, it might get higher. Researchers have already established that sea level rise is increasing. Most destructive superstorms are all but inevitable when you combine rising sea levels, rising temperatures with higher tides. It's almost inevitable. In the journal Earth Science Reviews, this is another study, 100 sites in Western Ireland were examined after the winter storms of 2013-2014, and they documented the displacement of, this is going to sound a little weird, 1,153 boulders. In other words, increased wave action, stronger wave action, starting to move boulders around that would normally not be reached by the wave action before the sea levels started to rise. That's basically what they're looking at. So why is this important? 40% of the people on the planet live close to the sea or by the sea. 40%. 50% live within 160 kilometers of shoreline. I can tell you that villages in Alaska have had to relocate because instead of the sea ice freezing, which is protective, protects the shoreline from storm battering and wave action, the sea ice is not freezing. So now there's all these storms slamming into the coastline, eroding whole chunks of cliffside, just eroding it right out. Whole villages have had to relocate, just pick up and move it in. So that's another consequence. When the sea ice does not form, the sea ice being a protective barrier against wave action, that protection is lost, and now you have exposed risk. Well, this is, no matter where you're at, increased wave action is going to be pummeling the coastline some more, with the result that you're going to be doing some damage. And this could be in terms of property, like Miami, okay? You know, that kind of stuff. Marinas, buildings, what have you, are going to get damaged. If you can start moving boulders around, you know, think what the persistent action against buildings and boats and so on and vehicles will do. Basically, engineers, coastal scientists, city authorities need to know what storm waters can do. So now that we know what storm waves are capable of, we have much more information for policymakers who are responsible for preparing coastal communities for the impact of high energy storms. This is a quote from Ronald Cox, a geoscientist at Williams College, Williamstown in Massachusetts. So I wanted to bring that story to you of some ongoing research that is going on. Please share this video. Please subscribe. Please become a patron. Patreon.com/Science Talk with Jim Massa. Thank you. Thank you for your time.